Now, let us do some of the important questions of real number that are already asked in the paper. Given that LCM 9126 equal to 182, then HCF equal to question mark. So, it's very easy to find it out. See, we know that the formula to solve it was HCF into LCM of two numbers equal to product of two numbers. So, using this formula, I can say LCM is 182, HCF I don't know, and the numbers are 91 and 26. So, I can directly say HCF will be 91 into 26 upon 182. So, 91 ones are, 91 twos are, 2 ones are, 2 13s are. So, HCF of 91 comma 26 is 13. So A option is the correct one. Now the second MCQ is if A equal to x cube y square, B equal to x y cube, where x and y are prime numbers, then LCM. So see, for LCM there was a shortcut key LCM of A comma B equal to whatever factors are there, I will write first x into y, and now the highest power. So x power highest power is 3, x highest power is 3, and y highest power is 3. So LCM of A comma B will be x cube y cube. Now the third question says if A equal to 2 cube into 3, B equal to 2 into 3 into pi, C equal to 3 raised to n into pi, and LCM of ABC equal to 2 cube into 3 square into pi. Then find the value of n. The options given to me are A1, B2, C3, D4. Now see, already we know that LCM means I have to write all the factors which are coming in the LCM first. So here I am writing 2 into 3 into 5 and highest power. So 2 cube, 3's highest power is 1 and n. So n I am writing and 5's highest power is 5. Now if I compare with the LCM, so n's value should be 2 because see, in LCM it is given 2 cube, 3 square and n 5. So the correct option is n equal to 2. Fourth one says the number root x plus root y into root x minus root y, where x is greater than y, is rational number, irrational, both or none. So now we know that see, a minus b into a plus b is equal to a square minus b square. So using this formula, if I do root x plus root y into root x minus root y, so it will be equal to root x whole square minus root y whole square. So that will be equal to x minus y. Now it is given that x is bigger than y. Therefore, x minus y will be always a rational number. So the correct option is A, rational number. Now, next question says product of two co-prime numbers is 117. Their LCM should be lies between 115 to 119, B 1, C 2, D 117. So already it is told that two co-prime numbers product is 117. So LCM is nothing but whatever common is there. So co-prime numbers only, common number will be 1. So here my correct answer will be 117. Next says the product of non-zero rational and an irrational number. Now see, irrational number means root number. So I can say root 2 if I multiply with 3, I will get 3 root 2. If I take 100 into root 3, so I will get 100 root 3. So always I am getting an irrational number. So my answer is always irrational. Now, seventh question says if m equal to p q cube and n equal to p cube q square, where p, q are prime numbers, then HCF of m comma n is. So, see, remember HCF, what was the formula? Write all the common factors first, p into q. Now, least power. So, in m, the least power of p is 1. And in Q's power is 3, whereas in n, P's power is 3 and Q's power is 2. So my HCF will be PQ square. So my A option is the right option. Next question says the exponent of phi in the prime factorization of 3750 is A 3, B 4, C 5, D 6. So let us do the prime factorization of 3750. So first with 2 I will cut. So I will get 1875. Then with 3 I will do. So I will get 625. Then with pi I will do. So I will get 125. Again with pi I will do. So I will get 25. Again with pi I will do. So I will get pi and pi 1. So here phi is repeated 4 times. So my correct option is B 4. Now, to solve this one, the ninth one says the greatest number which when divides 1251, 9377 and 15628 leaves remainder 123 respectively. So, here first I need to subtract the given numbers from the respective one. So, this will be 1251 minus 1 will be 1250. 9377 minus 2 will be 9375 and 15628 minus 3 will be equal to 15625. So now solving them to find the LCM of each one of them, 1250, if I do, I will get 3 factors of 1250. If prime factorization I get do 2, 625, 5, 125, 5, 25, 5, 5 and 5 1. So 1250 will be equal to 2 into 5 raised to 4. Same way, if I do 9375 factors, so first with 3 it will go 3, 1, 2, 5, then with 5, so 625, again with 5, so 125, again with 5, so 25, again with 5, so 5 and 5, 1. So 9375 will be equal to 3 into 5 raised to 5. And same way I have to do for 15625. So when I solve for that, 15625. So with 3 it will go first. So 15625. If I solve, I will get pi 3125, again with pi, so I will get 625, again with pi, so I will get 125, pi 25, pi, pi and pi 1. So that is equal to pi raised to 6. So now see, I have got common, that is pi raised to 5, pi is common, so I have to find the HCF. So that will be pi, which is common. Now the minimum power is 4. So 5 pi's are 25 and 25 pi's are 625. So my answer will be 625. 10th question says the LCM of two numbers is 2400. Which of the following cannot be the HCF? See, here by seeing only I can say okay, 500 will be the answer which won't be there. The reason for that is if you see carefully 2400 will be divisible by 300, 400 and 600. So only with 500 it won't get fully divided. So that is my answer which cannot come. Now next question says find the greatest number which is exactly divisible by 404 and 96. I have to find such a number which is divisible which which divides both of them exactly. So if I find the first the prime factorization, see here the number will be equal to HCF of 404 and 96. So if I find the prime factorization of 404, so 2 2s are 202, 2 again 101 and 101 is prime, so 1. Now 96 it will be 2, 48, 2, 24, 2, 12, 2, 6, 2, 3, 3, 1. So, therefore, I can say 404 equal to 2 square into 101 and 96 equal to 2 raised to 5 into 3. So, HCF equal to 2 square, that is 4. So, it will divide, 4 will be such a number which will exactly divide them. Next question is on a morning walk, three persons step off together and their steps measure 40 centimeter, 42 centimeter, and 45 centimeter respectively. What is the minimum distance each should walk so that he can cover the distance in complete steps? So, minimum distance they should cover or they should walk will be equal to LCM of 40, 42 and 45. So, if I solve them, so see 40, 2 20s are, 2 10s are, 2 5s are and 5 1s are. So 40 I can write as 2 cube into 5. Then second was 42 and third is 45. 45 means 9 into 5, so 3 square into 5. 42 again I am doing, so 2 21 3 771. So 2 into 3 into 7. So now LCM of 40. So LCM of 40, 42 and 45 will be, I will write 2 into 3 into 5 into 7. 7 is 1, so I will write 1 time only. 5 is also 1. 2 is maximum 3 times and 3 is 2 times. So 8 into 35 into 9. So this will come as 2520. So everybody has to move 2520 steps minimum. Next question is, find the least number that is divisible by all the numbers from 1 to 10, both inclusive. So here see, least is there, that means I have to find LCM. So 1 equal to, I can write as 1, I can write 1 into 1, 2 I can write 2 into 1, 3 I can write 3 into 1, 4 I can write as 2 square into 1, 5 I can write as 5 into 1, 6 I can write as 2 into 3, 7 I can write 7 into 1, 8 I can write 2 cube into 1, 9 I can write as 3 square into 1, and 10 I can write as 2 into 5. So LCM of 1 to 10 will be, see now maximum power of 2 is 3. Then maximum power of 3 is 2. Maximum power of 5 is 1. Maximum power of 7 is 1. So this comes as 40 into 63. So that will be 2520. Next question says 3 bells ring at an interval of 4, 7 and 14 minutes. All 3 bells rang at 6 a.m. When the 3 bells will ring together next. So see, here together is given. That means time when bell ring together next will be equal to LCM of 3. So that is 4 minutes, 7 minutes and 14 minutes. So if I want to find that, 4 I can write as 2 square, 7, 7 into 1 and the third one was 14. So 2 into 7. So if you see carefully, it will be 2 square into 7. So that is 4 into 7, that is 28 minutes. So that therefore the bell will ring together next at 6:28 a.m. Next question says, find the greatest number of 6 digit which is exactly divisible by 24, 15 and 36. So see, first greatest 6 digit number is 1, 2, 3, 4, 5, 6 times 6. Now LCM of 24, 15 and 36 is, if I find, see the LCM, so it will be 2 cube into 3 square into 5, that is 360. Now if I divide the greatest number 6 digit number with 360, whatever is left out, see 2s are 720, so 2799, then 7s are 2520, again the remainder is 2799, and again if I move 7, 2520, again the remainder is 2799, and again 2520. If I move 7, so 279 is left. Therefore the greatest number which is the greatest 6-digit number which is divisible by 24, 15 and 36 will be equal to 99999 minus 279. So that will be 0.27999. So this number is divisible exactly by that. Now next question says a fruit vendor has 990 apples and 945 oranges. He packs them into baskets. Each basket contains only one of the two fruits but in equal number. Find the number of fruits to be put in each basket in order to have minimum number of baskets. So number of apples is 990, number of oranges is 945. Therefore, number of fruits in each basket will be equal to HCF of 990, 945. So if I find HCF of 990 or prime factorization of 990 first, so 2, 495, then with 3, 3 ones are 3, 6 are 18, 1 5s are. Again with 3, 3 5s are 15, 1 3 5s are 5, 11, 11, 1. So 990 equal to 2 into 3 square into 5 into 11. And the other number is 945. So if I find for 945, 3, 315, again with 3, so 105, again with 3, so 3 3s are 9, 1 5s are, again with 5, so 7 7 1. So that is 3 cube into 5 into 7. So HCF is 3 square into 5. So that is 9 into 5, that is 45. So the number of fruits in each basket should be 45 to have exactly minimum baskets required. Next theorem 1.3 says root 2 is irrational. So to prove that, first let us assume that root 2 is rational. Therefore, root 2 is rational number and P and Q are co-prime numbers, co-prime integers, and Q is not equal to 0. Therefore, root 2 equal to P upon Q. Squaring both sides, root 2 whole square will be equal to P by Q whole square. So therefore, 2Q square equal to P square. Here, 2Q square is a multiple of 2 and hence it is even. Thus, P square is an even number. Therefore, P is also even. So, we can assume that P equal to 2x. where x is an integer. By substituting p equal to 2x in 2q square equal to p square, therefore 2q square equal to 2x whole square. So 2q square equal to 4x square. So therefore q square equal to 4x square upon 2, which is equal to 2x square. So therefore q square is an even number. Therefore q is also even number. Since p and q both are even number, they have 2 as a common multiple, which means that p and q are not coprime and HCF is equal to 2. But this is contradiction. Therefore, root 2 is irrational number. Now, example 5 says, prove that root 3 is irrational. So, this also we are taking by the assumption method. Let us assume that root 3 is rational number. Therefore, we can find integers a and b not equal to 0 such that root 3 will be equal to a upon b. Suppose a and b have a common factor other than 1, then we can divide by common factor and assume that a and b are coprime. Therefore, b root 3 equal to a. Now squaring both sides, implies b square into root 3 whole square equal to a square. So it implies 3b square equal to a square. Therefore, a square is divisible by 3. And according to theorem 1.3, a is also divisible by 3. Therefore, we can write a equal to 3c for some integer c. Substituting for a, we get 3b square equal to 3c whole square. So 3b square equal to 9c square. So therefore it implies b square will be 3c square. I have divided both sides by 3. This means that b square is divisible by 3 and so b is also divisible by 3. Therefore, A and B have at least 3 as a common factor. But this contradicts. Therefore, root 3 is irrational. Now exercise 1.2 question 1 says, prove that root 5 is irrational. So this again I will take the same method. Let root 5 be rational. Therefore, it can be written in the form written as P upon Q, where Q is not equal to 0 and P and Q are coprime. Therefore, root 5 equal to P upon Q. So therefore, root 5Q equal to P. Squaring both sides, 5Q square equal to P square. P square is divided by 5. Therefore, P equal to 5C. Squaring both sides, P square equal to 25C square. Now, putting 2 in 1, equation 2 in 1, I will have 5Q square equal to 25C square. So therefore Q square will be 25 upon 5 means 5C square. Therefore Q is divisible by 5. Thus P and Q have common factor of 5. But it contradicts the fact. Therefore root 5 is irrational. Now next question says, prove that 7 minus root 5 or 5 minus 3 root 2 or 3 plus 2 root 5 is irrational. So let us do all of them turn by turn. So let the first one I am taking, let 7 minus root 5 be rational number. So therefore 7 minus root 5 will be equal to A upon B, where A and B are co-prime and B not equal to 0. So therefore 7 minus A upon B equal to root 5. So 7B minus A upon B equal to root 5. So I can say that left hand side is rational number and RHS is irrational number. So they can't be equal. So therefore 7 minus root 5 is irrational. Now the second one is 5 minus 3 root 2. Let 5 minus 3 root 2 be rational number. So therefore 5 minus 3 root 2 will be equal to A upon B. So I can say where A and B are co-prime and B not equal to 0. So 5 minus A upon B equal to 3 root 2. Now this will be 5B minus A upon B equal to 3 root 2. So 5B minus A upon 3B will be equal to root 2. Now I can say LHS is rational and RHS is irrational. So they can't be equal. So therefore 5 minus 3 root 2 is irrational number. Then the third one was 3 plus 2 root 5 be rational number. So I am supposing it as let 3 plus 2 root 5 be rational number. So 3 plus 2 root 5 will be equal to A upon B, where A comma B are co-prime and B not equal to 0. So therefore 2 root 5 will be equal to A upon B minus 3. So 2 root 5 equal to A minus 3B upon B. So root 5 equal to A minus 3B upon 2B. So I can say that irrational is not equal to rational. Irrational not equal to rational. So therefore 3 plus 2 root 5 is irrational number. Now 20th one says show that 12 raised to n cannot end with the digit 0 or 5 for any natural number n. So to end in number with unit place 0 or 5, it should have factors 0 and 5. So 12 raised to n will be equal to 3 into 2 square whole raised to n, that is 3 raised to n into 2 raised to 2n. It is clearly seen that there is no 5 in the factor of 12, so it can't end with 10 or 5.